Hello everybody, welcome to our 12th and final session of Mastering the Basic Math Facts for Multiplication and Division. I'm Michael Elder and I'm glad to see you here one more time. We hope that this has been beneficial for you and that today's session will be one more chance to add a few more things to your toolbox for working with kids and their multiplication facts. So let's go ahead and take a look at where we are today with multiplying by sevens. Of course, you'll remember that we began at the beginning because that's a good place to start. We began with our foundational facts of 2s, 10s, 5s, 1s, and 0s, and we began to build on that, right? And we said, well, once we had those 5, we could figure out the rest of these. And so here we are now at multiplication by 7. Typically thought of as probably the most challenging multiplication fact for our kids, or the one that a lot of kids struggle with the most, and there's some good reasons for that. So let's take a look at why that is. There are some skip counting patterns, but they're not really as evident or as clear to kids. However, interestingly enough, if you have some, especially 4th, 5th grade kids, if they've been following football for a long time, sometimes they know their sevens because they've got their 1 touchdown, 2 touchdowns, 7, 14, 21, at least those first 3, 4, 5 that you see oftentimes in a football game. So, but the skip counting pattern, it just isn't as clear, right? There aren't really any good doubles to rely on. I mean, it's close to 6 and it's close to 8, but those aren't really convenient doubles. So that it makes it more difficult for kids. It's further away from their 5s and their 10s. We use our 5s and our 10s to solve a lot, but they don't help us here quite as much because it's just in the middle there. A lot of kids at this point are also still working on mastering their other facts, right? So when we get to this last fact of sevens, you know, that compounding factor of, well, I'm still trying to remember these certain facts over here, and now I've got to add sevens to that. The good news is, if they're really internalizing the idea of the commutative property and they're able to flip them around and think about them, there's only one new fact, right? The only new fact at this point is 7 times 7. So when we think about the known versus the unknown, again, kids, it's good to have them keep their own chart of which ones that they own, the ones they master, the ones they're still working on, and the ones that now there aren't any more upcoming. So it's very typical for kids across a classroom to be in different places, but if we can help them see there's really only that one more fact here. What are the big ideas when it comes to multiplying by 7? Of course, I didn't list the commutative property and the patterning. Those are certainly still true. The big one with multiplying by 7 is the distributive property, that I can break apart that 7 fact into whatever it is times 7. I can make that a 5 and a 2, right? Because 5 and 2 make 7. So if it's 6 times 7, I can think of that as 6 times 5 plus 6 times 2. Or I can break those 7 facts into times 6 and times groups of 6 and groups of 1. So it might be a good place to go back to the unifixed cubes and show, like we did with finding 9s. As you recall, when we did 9s, we thought of them as groups of 10 less 1. So that again is another example of the distributive property, but that's really one of the only big ideas when we come to multiplying by 7 that helps our kids really retain how the sevens work. One of the other piece that we focus on because of 7 times 7 is looking at square numbers, and why do we call them square? Where does that come from? So we'll look at that here in just a little bit. So our kind of ongoing questions as kids are working on a unit studying their sevens facts, does the order of the factors affect the product? Which 7 facts do I as a student already know? Which ones do I need more practice with to become more automatic? If I don't know the fact, how can I break it apart to make it more accessible for me? What are square numbers? And then how could I prove that a number is square? As with each of our units, we always have a literature connection thanks to our authors here. And so this time the text is Thunder Cake. And so in Thunder Cake, we'd certainly want to get kids thinking about what they're going to experience in the literature. And again, I would encourage you with Thunder Cake to think about, does this tie to any of my other standards? If I'm doing weather, this is a great place to tie weather in. And as well as just the recipe piece of this gives some nice math connections, some measurement connections. But in terms of just getting kids into the story, we're thinking about, well, what causes thunder? Where does it come from? How are thunder and lightning related? Why are some people afraid of thunder? Maybe there's some kids in your class that are afraid of a thunderstorm. And maybe they can think of some people that are afraid of thunder. So let's go ahead. We're going to listen to this story and see how the girl in the story overcomes her fear of thunder. While we're reading, we're gonna see that Grandma says that if you start counting when you see lightning, and you count 1 second, 2 seconds, 3 seconds, that'll tell you how many miles away the storm is. Grandma is slightly off in her understanding of how this works, but maybe that was because she wanted her granddaughter to be more comfortable and think the storm was further away. If you're doing this with kids, I'd encourage you to work with them. This is a great place to tie in our fives facts, right? Because it's really the speed of light and the speed of sound is about a 5 factor. So about every 5 seconds tells us it's about a mile, right? So good connection to division by 5. Not quite how Grandma played it out in the story, but let's go ahead and flip over to our story. And again, the purpose of the story is to give our kids, and all of us really, a context for understanding our multiplication fact. So we can go back in our memories and remember the story sometimes easier than we can just a fact. So this is Thunder Cake by Patricia Polacco. Oops, did I skip the first? I did, sorry. On sultry summer days at my grandma's farm in Michigan, the air gets damp and heavy. Storm clouds drift low over the fields and birds fly close to the ground. The clouds glow for an instant with a sharp, crackling light, and then a roaring, low, tumbling sound of thunder makes the windows shudder in their panes. The sound used to scare me when I was little. I loved to go to Grandma's house. Babushka, as I used to call my grandma, had come from Russia years before. But I feared Michigan's summer storms. I feared the sound of thunder more than anything. I always hid under the bed when the storm moved near the farmhouse. This is the story of how my grandma, my babushka, helped me overcome my fear of thunderstorms. Grandma looked at the horizon. She drew a deep breath and said, "This is thunder cake baking weather, all right. Looks like a storm's coming to me." "Child, you come out from under that bed. It's only thunder you're hearing," my grandma said. The air was hot, heavy, damp. A loud clap of thunder shook the house and rattled the windows and made me grab her close. "Steady, child," she cooed. "Unless you let go of me, we won't be able to make a thunder cake today." Thunder cake?" I stammered as I hugged her even closer. "Oh, don't pay attention to that old thunder except to see how close the storm is getting. When you see the lightning, you start counting real slow. When you hear that thunder, you stop counting. That number is how many miles away the storm is. Understand?" she asked. "We need to know how far the storm is so we have time to make the thunder cake and get it in the oven before the storm comes, or it won't be a real thunder cake." Her eyes surveyed the black clouds that were way off in the distance, and then she strode into the kitchen. Her worn hands pulled a thick book from the shelf above the wood stove. "Let's find that recipe, child," she crowed as she lovingly figured out the grease-stained pages to a creased spot. "Ha! Here it is. Thunder cake." She carefully penned the ingredients on a piece of notepaper. "Now let's gather all we'll need," she exclaimed as she scurried towards the back door. We were by the barn door when a huge bolt of lightning flashed. I started counting like Grandma told me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the thunder roared. 10 miles! It's 10 miles away," Grandma said as she looked at the sky. "About an hour away, I'd say. You have to hurry, child. Gather them eggs careful-like," she said. Eggs from mean old Nellie Peck Hen. I was scared. I knew she was going to try to peck me. "Oh, I'm here. She won't hurt you. Just get them eggs," Grandma said softly. The lightning flashed again. 1, 2, 3, 4, 5, 6, 7, 8, 9, I counted. 9 miles, Grandma reminded me. Milk was next. Milk from old Kick Cow. As Grandma milked her, Kick Cow turned and looked mean right at me. I was scared. She looked so big. Zip went the lightning. 1, 2, 3, 4, 5, 6, 7, 8, I counted. Boom went the thunder. 8 miles, child, Grandma croaked. Now we have to get chocolate and sugar and flour from the dry shed. I was scared as we walked down that path from the farmhouse through the tangleweed woods to the dry shed. Suddenly the lightning split the sky. 1, 2, 3, 4, 5, 6, 7, I counted. Boom! Ba-boom! Crashed the thunder. It scared me a lot, but I kept walking with Grandma. Another jagged edge of lightning flashed as I crept into the shed. 1, 2, 3, 4, 5, 6, I counted. Boom! Kaboom! The thunder bellowed. It was dark and I was scared. I'm here, child, Grandma said softly from the doorway. Hurry now, we haven't got much time. We've got everything but the secret ingredient. 3 overripe tomatoes and some strawberries, Grandma whispered as she squinted at the list. I climbed up high on the trellis. The ground looked a long way down and I was scared. I'm here, child, she said. Her voice was steady and soft. You won't fall. I reached 3 luscious tomatoes while she picked strawberries. Lightning again. 1, 2, 3, 4, 5, I counted. Ka-bang! Boom! The thunder growled. We hurried back to the house in the warm kitchen and measured the ingredients. I poured them into the mixing bowl while Grandma mixed. I churned butter for the frosting and melted the chocolate. Finally, we poured the batter into the cake pans and put them into the oven together. Lightning lit the sky. I only counted to 3 and the thunder rumbled and crashed. 3 miles away, Grandma said, and the cake is in the oven. We made it. We'll have a real thunder cake. As we waited for the cake, Grandma looked out the window for a long time. Why, you aren't afraid of thunder. You're too brave, she said as she looked right at me. I'm not brave, Grandma, I said. I was under the bed, remember? But you got out from under it, she answered. And you got eggs from old Nellie Peckhen. You got milk from the old Kick Cow. You went through the tangleweed woods to the dry shed. You climbed the trellis on the barnyard. From where I sit, only a very brave person could have done all them things. I thought and I thought as that storm rumbled closer. She was right. I was brave. Brave people can't be afraid of a sound, child, she said, as she spread out the tablecloth and set the table. When we were done, we hurried into the kitchen to take the cake out of the oven. After the cake had cooled, we frosted it. Just then the lightning flashed, and this time it lit the whole sky. Even before the light flash had faded, the thunder rolled. Boom! Crash! Just above us. The storm was here. Perfect, Grandma cooed. Just perfect. She beamed as she added the last strawberry to the glistening chocolate frosting on top of our thunder cake. As rain poured down on our roof, Grandma cut a wedge for each of us. She poured us steaming cups of tea from the samovar. When the thunder roared above us, it shook the windows hard and rattled the dishes in the cupboards. We just smiled and ate our thunder cake. From that time on, I never feared the voice of the thunder again. In the back of the book is the recipe for Grandma's thunder cake. So again, just another nice little connection that we can make. So as we finish the reading of the story, we might want to bring kids' attention back to, what was needed to bake the thunder cake. We could pull out the recipe. We could look at those. We can use those numbers in a lot of ways. But the way we're going to pull our sevens facts in here is to ask about what was the last ingredient that Grandma added to the top of the cake. And you might remember that those were the strawberries, right, that she put on top of the cake. And Conveniently, how many strawberries does she have on the cake? Well, as we count them, we see that she has 6 on the cake, and she's about to put that last one on there. So there are 7 strawberries on the cake. And of course, the teacher in us is going to pull that in and make sure that our kids get that there are 7 strawberries and that we can extend that, right? So we want to build this context for understanding multiplication by 7. So we might ask, well, if grandma made 7 cakes, so grandma's going to have, she has an order for 7 cakes, or there's a big party, she wants to do 7 of them. Well, how many strawberries is she going to need? Now, we have to remember this is 7 times 7, so this is the one fact that kids haven't had much experience with. So we want to make sure to give them manipulatives, drawing paper. Some are going to need that concrete. Some are going to be able to go straight to representational at this point because they've had so many experiences with multiplication facts. We're going to look to see how are kids solving this, right? Did they build arrays? Did they go straight to multiplication? Did they use a multiplication fact they already know? Did they use, say, 5 times 7 because they know that one, or 6 times 7 and just add 7 more to it? Did they break it apart into groups of 5 or 5 groups and 2 groups? So you're looking to see how are kids attacking this problem. The worksheet here on the screen gives you a way to kind of capture what they're thinking. And then we're going to jot down for them, okay, so what is the multiplication equation we're looking at? Well, 7 times 7 is 49. And so now we want to extend, right? How many would she need to make 5 cakes, 6 cakes, 9 cakes? Are they using the commutative property? They remember we already did 9 times 7, right? So this is now 7 groups. This is now 9 groups of 7. So can they flip that around and say, do I remember what 9 times 7 is? Can I use what I know about 10 times 7? And all those strategies that they've been building up are key at this point if they've really made the connection. And it's okay for them to not have completely made the connection, and we're going to help walk them back through that. Let's use some of the strategies we've used throughout this. So one of the things that we said that was a big idea with multiplying by 7, or that we're going to bring attention to, is this idea of square numbers, right? And so they've been building arrays if we've done the different activities in the different chapters. So they've looked at a whole bunch of rectangular arrays here, and some of those happen to form squares, right? And squares we know are special rectangles. The rectangles that happen to have lengths, 4 sides that are the same length. They are still rectangles, but they're special, and we call them squares, right? So we want kids to explore these. Let's take a look at what a 2 square looks like, a 3, a 4, a 5, a 6, a 7, and 8. So we have this sheet here, right? We're going to ask kids to actually create those various arrays, to label them with the fact. And once they've created all of them, we can extend this using centimeter grid paper if we wanted to do all the way up to 10 by 10. But what we're really looking for them, or hoping that they can see in these, is that an array that has the same length and the same width is going to create a square. That we didn't just make up the word square numbers, right? But that the reason that we call them square numbers is that they actually form squares. And so oftentimes that's something that kids and sometimes even adults haven't picked up on, is that the reason we call them square numbers is because they create squares when we build the array, in the same way that later on we teach kids about length, width, and height, and we call that if it has the same length, the same width, and the same height, it forms a cube, and that's why we call them cube, is that it forms a cube when we have that shape. So anyway, back to our square numbers, right? We want kids to start to build that knowledge for themselves. It's easy to tell kids, look, they make a square, but if we can get them to draw them out, to start to realize, well, why isn't a 2 by 3 a square? Why is it just a rectangle? Well, we wouldn't call it a square number then, right? So giving our kids that need a lot more experiences, most kids are going to need a lot of experience by this point. They're going to have a lot of experience, but they're going to need a lot when it comes to 7s. So riddles are kind of fun ways to get at these through language, right? So things like, I'm a multiple of 7, I'm greater than 20, I'm less than 40, one of my digits is a 5. What am I? Can they go, okay, well, 21 and then 28 and 35. Oh, it must be 35, right? Because one of my digits is 5. So I'm a multiple of 7. I'm greater than 14. My other factor is a 3. I'm a multiple of 7. Both my digits are even. I'm less than 40. once kids get into the routine of this, these are great to write for all our numbers. So you can certainly assign different facts to different kids, especially if you have kids that are struggling at this point. They can go back and do riddles for their twos facts, and build a book of mathematical riddles, right? Another way to give kids multiple experiences with their sevens facts, right? We can go back to our grid paper. We're going to outline all of our sevens facts. We're going to label them with their multiplication equation on them. These are great to hang around the room to make a great bulletin board. If you use something bigger than centimeter grid paper, it might be a good place to bring in inch grid paper. Makes them a little bit more noticeable, and to hang them around on a bulletin board or to hang them around in the room gives that visual reminder that these multiplication facts do actually mean something. They aren't just something to remember. So again, just like in all of our other pieces, once we've given kids a number, a sufficient amount of time and a sufficient amount of exercises with the facts, we're looking at then building automaticity. So we know we have our fact cards. Not all kids are going to be on their sevens facts at the same time. It's important to individualize these for kids. So we've got our multiplication and our division fact cards that are included in the digital downloads. We've got our fact checks, right? So we can go in and see how kids are doing with these. If I know a child is struggling and they're not ready for these, it is not important that they are all in the same place or all doing the same fact on the same week. It's very, very easy to keep track of in terms of giving these kids are on their twos, their threes, their sixes, their nines. And these kids happen to be on their sevens. Using sheets like this takes a couple minutes in advance to go ahead and put kids' names on the sheet they get. And when they're passed out, they just get the one that has their name on it, right? And that happens to be the fact that they're working on. Relatively easy to keep up with on a chart too. And good communication with parents. Again, building automaticity takes time, takes different experiences for different kids, just like all of us. We're going to learn it. Something's going to click for a different group of kids. So spinning facts is one activity that we haven't done yet. So this one is going to be using a spinner like so many of our things have, right? So they're going to spin the spinner twice, and they're going to multiply the two digits together. Then they're going to cover up that product on the board. And your goal, right, is to create a row or a diagonal that is filled in, right? So when I spin it twice, I'm going to get 7 times 6, 7 times 9, 7 times 8, or 8 times those, right? So there's only so many combinations here, and by focusing on these 4 facts, we're working on probably the ones that kids are going to struggle with the most at this point. Again, these are all in word form, so for a student who's not there yet, it's very easy to change those values to something that works for them. And then another activity is called Target 70. Right? So they're going to spin the spinner. So this spinner this time. They're going to multiply by 7. So if I spun a 5, I'd get 35. Right? So I'm going to write that down. I'm going to spin again, and I get 2 times 7. That's 14, and I get 4 times 7. That's 28. And I get to add my 2 that I want, the 2 highest ones probably, and I'm going to try to get to 70. Again, I guess it would depend. If I got 10 times 7, then I'm going to try to, I don't want to add much to that, right? So I might not add the 2 biggest ones. The first player to win 2 rounds wins, so you have the see for player 1 and player 2. They're 3 products, they're going to add them together, they're going to get their sum, and are they the closest to 70 for that? So again, one that's relatively easy to do again and again. Kids can certainly work around. We've talked about that with games too. Oops. Jumped ahead too far, that you could have a progression, right? So the winner of this table moves to that table, the loser slides back. Doing those kind of things is kind of fun with kids too. Math Facts Face Off, very similar to War, the card game of War, right? We're not going to focus on speed though, so I'm going to pull my 2 cards and multiply my 2 cards together. Once I multiply my 2 cards together, then my partner is going to do they're going to pull their 2. They can do them at the same time, actually. And then whoever has the largest product and can correctly identify the product gets to keep the cards. And if you have if you tie, we both pull 3 and 4, so we both get 12. Then we put those ones down, and we each pull again. And so, again, whoever gets the largest value is going to get to keep their cards. And the player at the end of the deck that has the most wins. As we're monitoring, right, at this point, we've been doing multiplication for so long, And again, it's probably going to take the entire year. There's going to be some kids moving into 4th grade, some kids moving into 5th grade. Kids in 6th, 7th, 8th grade, if they haven't had a lot of experiences, they need to have the experiences if they're going to remember their facts, right? So we're looking at which facts are automatic, which facts slow them down, and which facts are just, I don't know how to get there, right? Different strategies for different problems for kids are important. Eliminating 10, right, becomes another way to play with our 7s facts. So we're going to spread out or eliminate 10 cards. We're going to shuffle these decks of the division cards and put them in a stack face down for them. I'm going to pull out a card as the participant. If the quotient matches one of these, right, then I get to turn it over or take it away. And the first person to cover all my card, to cover all the cards on theirs wins, right? So if I pulled 21 divided by 3, I'd say, oh, that's 7. So now, again, we're moving into the division here. So 21, I say 21 divided by 3. So I'm looking for the 7, so I get to eliminate that one, right? So I'm going to try to eliminate 10 of these facts on here. And once I've done that, then I win, or you can play the whole card. Again, just a good way to get into practicing. Target 7 is going to look a lot like target 7D, right? Except for now, since we're dividing, I'm not going to get large values. I'm going to get relatively small values. So same kind of thing, right? I'm going to spin, but I'm going to divide this time. Get my 3 quotients, so my 3 answers to those questions. So if I got 70 divided by 7, that gives me 10. And let's say 28 divided by 7, and I get 4. So now, and I would spin a third time. So let's say I just want to use my 10 and my 4. I'm going to add those together. That gives me 14. And then is my opponent closer to 7, or are they further away from 7? So that brings us to the closure of this professional development, not just the closure of the divided by 7s, right? A couple things that hopefully have come across in this professional development for you is that we certainly want kids to have good fluency, to have automaticity with their multiplication facts, but that's not our only goal in teaching math, right? There are as important goals out there. Helping kids realize that math is not a game, or is not a game. It's also not a series of tricks that I have to remember. We go back to, again, if I'm trying to remember the trick, if that over time becomes the memory, right, is the trick. Well, how do I remember the trick? And sometimes I can remember the trick, and sometimes I can't remember the trick. Doesn't do me good in the long run. So a focus on patterns, on properties, on operations, that's the understanding. That's number sense, right? And we all say we want kids and adults to have good number sense. So if we're going to have good number sense, we have to focus on number sense in our instruction. So there are 8 little reminders here, right, that we've got to explore meaning over just memorization. The sequence that we present facts in is important. Honoring that different kids are in different places is really important. Talking and writing about math facts is important. We have to remember that automaticity takes time, and unfortunately it's not always in the time that we'd like for it to be as teachers, and it's also not always the same for each kid, and so it's never the same for all of our kids. That fluency is definitely a goal. We want to give kids the skills they need to be quicker with their facts, to use less working memory, but we de-emphasize the focus on speed, and ultimately we get what we want, right? We ultimately get kids to know the facts and to do them quickly. We know that some kids are going to require extra support. So some kids are going to need all the games. Some kids are only going to need some. But some kids are also going to appear they know the facts, but they've only memorized them. So sometimes the activities or the games are important to get them into the conceptual understanding. Because that's really what they need when they get into algebraic thinking, right? So mastery of math facts, as we mentioned, is only one part of being a competent mathematician. And we have to own as teachers that how I teach and how I assess can either help kids have less anxiety, or it can create anxiety for kids. If we realize that what we're doing is creating an unnecessary level of anxiety, we've got to adjust what we're doing as educational professionals. We really, in the end, right, we all want kids to feel competent based upon their skills, right? and that we want kids to believe they have the ability to learn. It might take me more practice than my neighbor, but I have the ability to do this. So as we close out this final session, you'll see in your assignment that we ask you these 4 questions, right? As we've gone through this, we know there's things we can do better, or I can do better in this. So I'd love your feedback on that. So what could we do to make this PD more meaningful to you? What's one thing that you personally are taking away from this professional development that you can add to your toolbox, or that you'll change about how you approach math facts? If there is something like that, it might just be one of the games, and that's fine too. This might have just been very affirming for you in the things you do too. So that's the third question, is what has been affirmed for you about what you believe about math facts, or about how kids learn, or how you approach instruction. And then the fourth thing, this is a new foray for us into online professional development. So we're asking you, is this something that you would like to see more developed in, not just math facts, but other math topics and those kind of things. So those are your final 4 questions, and then we will check you off on that. And we hope this has been beneficial to you. We know that teacher time is a premium, and so we thank you for spending your time with myself, and earlier with Shelley on the addition and subtraction part of this. So thank you again for your time, and as always, please contact me if I can help you in any way.